Hello everyone and welcome back. Today we're going to continue our conversation about implicit differentiation, and we're going to add to it a little lesson on tangent lines and tie those two concepts together. We've already talked a lot about tangent lines, but now we're going to tie it together with the implicit differentiation. A lot of the problems that we look at and tackle today are going to be AP type problems, so make sure you're taking great notes and following along with me, pausing and rewinding and rewatching when necessary. Okay, this first example asks us to find the equation of the line tangent to the graph. So we have answered these kind of questions over and over again. Just a reminder, what are the two things we need to write the equation of a line? Well, we need our point, which in this question we are given right here, and we also need our slope. So last class we talked about finding the slope of an equation when you have x's and y's on the same side of the equal sign, and we use implicit differentiation to do that. So that's what we're going to do to get started on this. Alright, so we're going to take the derivative of the left and right hand side. Okay, so the derivative of x cubed is 3x squared plus, now we have 2xy, so we're going to use the product rule, and 2x is going to be our first and y is going to be our second. Okay, so sorry I kind of covered that up. So it's going to be 2x times the derivative of y. Remember, the derivative of y would be 1 times dy dx. So we're just going to put the dy dx. Okay, plus our second is our y times the derivative of 2x is 2. Plus the derivative of y cubed would be 3y squared. Dy dx is equal to the derivative of 3 is 0. Alright, so remember we collect our dy dx terms on one side. Alright, so that would be 2x dy dx and 3y squared dy dx is equal to, everything that is not a dy dx term gets shoved to the other side. So we have negative 3x squared and we have minus 2y. Alright, so dy dx gets factored out. And some of this you're going to start doing in your head, this next two steps, okay? So dy dx gets factored out and we're left with 2x plus 3y squared is equal to negative 3x squared minus 2y. And then you're going to divide that over. So dy dx equals negative 3x squared minus 2y all over 2x plus 3y squared. Okay, so now we're going to go ahead and that's our derivative, that's our slope. We are going to find that slope, dy dx, at the point negative 1, 2. And so that means that our negative 1 is our x value and our y value is the 2. So we're going to go ahead and plug those into the slope for the given x and y values. So you'd have negative 3 times negative 1 squared minus 2 times 2 all over 2 times negative 1 plus 3 times 2 squared. Okay, so in my head, negative 3 times negative 1 squared is 1, so that's just negative 3, minus 4 is negative 7, and in the denominator I have 2 times negative 1 is negative 2, plus 3 times 2 squared is 4, 4 times 3 is 12, so negative 2 plus 12 is 10. So our slope is negative 7/10, and our point was negative 1, 2. So I'm ready now to put the two of those together and write the equation of the tangent line. Y minus 2 is equal to negative 7/10 x plus 1. And that is our answer for the equation of the line tangent at that point. Okay, so if we look at this next question, this would be a classic AP type question, okay? Consider the given curve and find all points. So be careful there, you notice all points. That means there may be more than one, if any, so there might not be any, at which the graph of the equation has a horizontal tangent line. Okay, remember horizontal tangent line we've talked about. Well, horizontal tangent lines, what do they look like on a graph? Well, if I have it's where I have a relative min or a relative max. And so when I have a horizontal tangent line, my slope is 0. That's going to be very important here. Okay? And write the equation of each horizontal tangent line to the curve. Again, we're writing equations of tangent lines where our slope is 0. Okay? And so we do still need a point. We need the point for which at which our slope is 0. So this is one of those questions where they are giving us the slope, and what we need to do is find the derivative of the given equation and then set that derivative equal to our given slope, which in this case is 0. Then solve and go forward from there. All right, so what I'd like you to do is pause the video, go ahead and take the derivative of the given equation, and then come back to me and see if you get the same thing I do. Okay, so take a look at the derivative I got, match it up, make sure it's the same as the derivative that you got. Notice that I did factor out and cancel out a 2 out of each of the terms here, down here. All right, so, all right, moving forward. Now what we need to do is go ahead and set that derivative equal to 0. So I'm going to take, okay, the equation dy dx equals 4 minus 4x over y plus 2, and I'm going to go ahead and set the derivative to be 0. So I'm going to actually write that as 0 over 1. And we do this because, of course, we know that 0 divided by any number is actually equal to 0. Okay? Now, if you look at what we have here, all right, we have a fraction set equal to a fraction. Hopefully your gut is telling you to go ahead and cross multiply to solve this. So when I do that, I get 4 minus 4x is equal to 0 times y plus 2 is just 0. All right, and then this becomes a pretty easy equation to solve. 4 equals 4x, and so x is equal to 1. Okay, so now we have our x value of our point or points for which we are going to have our horizontal tangent line. So we have our x value, we need our y values. So where am I going to go to get my y values for the points for the original curve? Hopefully you're guessing this correctly. Yes, we're going to go back to the original equation. Okay. Okay, so if I take that x value and I plug it back into the original here, this one here, okay? So I'm going to put in, everywhere where I see an x, I'm going to put in a 1. So that would be 4 times 1 squared, which is just 4 times 1, plus y squared, minus 8 times 1, plus 4y, plus 4 is equal to 0. Okay, now I'm going to go ahead and solve this equation for y. So we'd have y squared plus 4y, and now I have 4 minus 8 is negative 4, plus 4 is 0, so just equals 0. All right, hopefully you recognize that you can factor this pretty quickly. And then we're going to go ahead and t-chart that, and so we get y equals 0 and y equals negative 4. So now I have my two y values, okay, for this, and so that means I have two different points, both with an x coordinate of 1. So I have the points 1, 0, and I have the points 1, negative 4. So what that would kind of look like on a graph, all right, is here I have the point 1, 0, and then I also have a point 1, negative 4. So those are my 2 points that the graph has a horizontal tangent at. So you can kind of envision this, that maybe you have like a circular graph, okay, something like this. And so your horizontal tangent lines are drawn there and there. All right, so now the last thing the question did ask us to do was not only name the points, which we have right here, but also write the equations. Well, we know our slope is 0, so all horizontal lines with a slope of 0 are just y equals, and then it's whatever the y value is. So this one's going to be y equals 0, and this one's going to be y equals negative 4. All right, and that concludes the first part of this question. Okay, so the second part of this question is pretty similar to the first part. It's just that instead it says find all points. So again, remember that means that there could be more than one, if any, there could be none, at which the graph of the equation has a vertical tangent line. Write the equation of each vertical tangent line to the curve. All right, so now if we have a vertical tangent line, what is that telling us? Well, it's now telling us that instead of our slope being 0, we now have a slope that's undefined. And if we have an undefined slope, we know that what that looks like is that instead of 0 divided by a number, it's a number divided by 0. Okay, so we're going to grab that slope that we actually found in part A, and we're going to rewrite it. Okay, so that slope that we found in part A was dy dx equals 4 minus 2x over y plus 2. And now, instead of setting that slope equal to 0 over 1, we're going to go ahead and set it equal to 1 over 0. So 4 minus 2x plus 2. All right, so this time when we cross multiply, we're going to get y plus 2 is equal to 0. And so y simply equals negative 2. So now we know that our point or points will have a y value of negative 2. Our job now is to find the x value for this point or points. So where do we go to get the x values for the graph? Hopefully you remember from last time, we're going to go back to the original. Okay, so we're going to go back to the original. So I'm going to take that y value and plug it in. So 4x squared plus negative 2 squared would be 4 minus 8x plus 4 times negative 2 would be minus 8, and then plus 4 equals 0. Okay, so I'm going to clean this up, and I'd have, I think this was a minus here, so I'd have 4x squared minus 8x, and then I have 4 minus 8 is negative 4, plus 4 is 0 again, and so that's just 4x squared minus 8x. Again, very easy to factor out a GCF, and we're left with x minus 2 equal to 0. So when I solve each part of this, I get x to be 0 and x to be 2. Okay, so now I have my x values of the points. Okay, now you can clearly see that there are 2 points. There is the point 0, negative 2, and there is the point 2, negative 2. Okay, so visually, if I wanted to kind of take a look at this again, what does this look like? All right, so here I can plot these 2 points. 0, negative 2 would be here, and 2, negative 2 would be here. So again, we can kind of envision our graph probably being something pretty circular. And so our equations of our tangent lines, our vertical tangent lines, are going to be here and here at those points. Okay, so the equations of these lines that we just drew, well, we know that vertical lines with undefined slopes have equations that start with x equals. So what are the x values of these points? X equals 0, x equals 2. So there are the equations of the vertical tangent lines, and here were the points for which the graph was tangent to those lines. All right, moving on. Okay, this third example, again, has a couple parts to it. Consider the curve in the xy plane given by that equation. Find all points on the curve with the x coordinate of 3. Okay, so here they are giving us the x coordinate. They want the points on the original curve. They're not talking about the slope. They're not talking about anything else. This is a very quick, should be a very direct question. So they're giving you the x coordinates of these point or points, and they want the y. So what do I do? Well, here's the equation of the original curve. So we're going to go ahead and put the 3 in for x. So instead of x squared, I'm going to have 3 squared, which is 9 minus 3y equals y squared minus 1. Okay, so I'm going to go ahead and solve this. It's a quadratic, so I want to set it equal to 0. So I'm going to have y squared, bring my 3y over, it'd be plus 3y, minus the 9 would be minus 10. Okay, I should be able to factor this pretty quickly. 2 numbers that multiply to negative 10, add to 3 would be plus 5, minus 2. So I can solve each of these factors. So y equals negative 5 and y equals 2. All right, so those are my y values, and here was my x coordinate. So I put the 2 of those together, and I have 2 points. So I have 3, negative 5, and I have 3, 2. So those are the 2 points that have an x coordinate of 3. Okay, part B of this question is getting into that idea of a tangent line again, okay? So write the equations of the lines, so more than one line, tangent to the curve at the points found in part A. So here I remembered the points I found in part A, and I just jotted them down for us. Okay, so now if we're talking about writing the equation of the line's tangent, so we're going to have two different lines, one that is tangent at this point and one that is tangent at this point. What do I need for each of those lines? I need the slope. Where do I find the slope? I do the derivative. Okay, so I'm going to go ahead and take my equation and do the derivative of both sides. Okay, so I start off with the derivative of x squared, which is 2x. Okay, minus, now xy is a product, so I'm going to go ahead and do the derivative using the product rule. First times the derivative of the second. Okay, the derivative of y would be 1 and then dy dx. So I just need to write down the dy dx. Okay, plus the second would be the y times the derivative of x would be 1. Okay, and then is equal to the derivative of y squared is 2y dy dx. Derivative of negative 1 is 0. All right, so I'm going to go ahead and distribute this negative right on through here. So I'd have 2x minus x dy dx minus y is equal to 2y dy dx. All right, so I'm going to collect my stuff on either side. So I'd have negative x dy dx minus 2y dy dx equals, add the y over, subtract the 2x over. All right. If I factored out my dy dx here, I'm going to have negative x minus 2y equals y minus 2x. Divide that over, and my slope is equal to y minus 2x over negative x minus 2y. Okay, now remember, I have 2 points. So I have to find the slope at each of these points in order to write a line tangent at each of those points. Okay, so over here I'm going to go ahead and do my dy dx for each of these at each of these points. So at the point 3, negative 5, what's that going to look like? All right, so remember your 3 is your x value and your negative 5 is your y value. So I'd have negative 5, plugging it into this right here. So negative 5 minus 2 times 3 over negative 3 minus 2 times negative 5. All right, so let's do some figuring here. Negative 5 minus 6 would be negative 11 over negative 3. This is going to turn into plus 10, so that would be 7. So here my slope is negative 11 sevenths at the point 3, negative 5. So I'm ready to write the equation of the tangent line, which would be y plus 5 equals negative 11 sevenths x minus 3. So that's my first tangent line. Okay, so now I'm going to repeat that same process with the second point. So dy dx at the point 3, 2. Okay, so again, x goes in, 3 goes in for x, 2 goes in for y. So I'd have 2 minus 2 times 3 over negative 3 minus 2 times 2. Okay, so on the top here, 2 minus 6 would be negative 4. And on the bottom, negative 3 minus 4 would be negative 7. So we can see that that would be equal to 4 sevenths. And that's our slope, okay, at the point 3, 2. So I'm ready to write my tangent line. It'd be y minus 2 is equal to 4 sevenths x minus 3. All right. Okay, the last part of this question and the last question that we're going to tackle today, you probably hear my kids laughing very loudly in the background. Find all points, again, points, more than one, on the curve where the line tangent to the curve has a slope of 4 sevenths. Okay, so here again is an opportunity where they're giving us the slope and they're asking for the points where the line is tangent has that slope. Okay, so when they give us the slope, we want to take the derivative which we actually found in part B, and we're going to set it equal to this slope. All right, so we take that derivative that we found from part B, which was dy dx equals y minus 2x over negative x minus 2y. Okay, so this was the slope that we had, and it was 4/7. So I'm going to put 4/7 in for dy dx, y minus 2x over negative x minus 2y. And we're going to go ahead and cross multiply. Again, hopefully that's what your gut is telling you to do. So we'd get 7y minus 14x equals negative 4x minus 8y. All right, so clearly I'm not going to be able to solve for one variable completely because we have two variables here. So what we're going to do is bring our x's to one side and our y's to the other. So as I do this, I would have, if I brought my y's over to this side, I'd have 15y is equal to 10x. All right, now at this point, you can solve for either x or y. It does not matter. I'm just going to go ahead and solve for y by dividing by 15. Again, you're solving for one of the variables in terms of the other. So this would be like 2x over 3. So clearly I do not have a value for y yet. Okay, so this is y in terms of x, and I need to actually know what x and y are. The only equation that I can go back to, because remember, you're finding the points on the original curve. Okay, so if I have something that I need to work with and I need points on the original curve, I'm going to go back to the original equation. So I'm going to take that original equation, and if I substitute in everywhere where I see a y, if I substitute in this 2x over 3, well then now all of a sudden I have an equation that only has one variable, namely x. So we're going to go ahead and do that. All right, so I'm going to take x squared minus x times, instead of y, I'm going to put 2x over 3. All right, equals 2x over 3 squared minus 1. All right, so I'm going to multiply this out. So x squared minus, this would be 2x squared over 3, because of course that x is like over 1, is equal to, when I square a fraction, I square the top, 4x squared, and I square the bottom, minus 1. All right, so here we have a fractions inside of a equation. I want to go ahead and make this all one line, and so I'm going to go ahead and multiply both sides by my common denominator, which would be 9. And that should eliminate all my fractions. So I'd have 9x squared minus, the 3 would go into the 9 3 times, leaving 3 times 2x squared, so 6x squared, is equal to, here the 9's completely cancel, and so we just have 4x squared, and then minus, of course, 1 times 9 would be 9, because I'm multiplying that to both terms. All right, so now we can go ahead and kind of clean this up. 9x squared minus 6x squared would be 3x squared. If I brought the 4x squared over, if I subtracted that over, I'd have negative 1x squared equals negative 9. So x squared would equal 9. So x would equal, don't forget, plus or minus. Okay, so when we take the square root within an equation, of course, you have to remember it's plus or minus, positive or negative 3 there. All right, so there's my x values, and we're almost done. Those are the x values of my points, okay? So here we have 3 comma something, and we have negative 3 comma something. Where do I find my y values? Well, go back over here, okay, and look at what we have. Y equals 2x over 3. So we solved for y earlier in terms of x. Now we found our x's. To now go back and get our y's, we put those x's in, and then we will have our y's. So y equals, all right, first for when x is 3, okay, y equals 2 times 3 over 3. Well, that's simply just 2. So when x is 3, y is 2. And the second one was y equals, now we have x as negative 3. So y equals 2 times negative 3 over 3. So that's going to be negative 2. So when x was negative 3, y was negative 2. And there are our 2 points on the curve where the line tangent to the curve has a slope of 4/7. Okay, great job today, guys. I really want you to go back and make sure that you have a clear understanding. You know, think through all these different scenarios. If they're giving you the slope, you need the derivative. If they're giving you an x point and they want the y on the original curve, you're going to the original. So you really want to process through in your brain. When are you using the original? When are you grabbing the slope? what are you setting it equal to, and really being able to follow through then in a lot of algebra again as we work through these problems. Okay, I will see you in class next time, and we'll be practicing more of these problems.